Have you seen something like this before? A self-balancing toy? Look at that. Do you see it? It's just balancing on that single point, even though there are two steel balls sticking out on each side. How is that even possible? How is it not tipping over? Well, let's try to see if we can find out the physics behind this in this particular video. So, what exactly is physics here? Well, at its heart, physics helps us understand why things stand, fall, or survive forces around them. Think about it. A building needs to stay up, and even though gravity is pulling it down, and wind is constantly pushing it from the side. Crazy, right? Yes. And the physicist constantly asks what makes something stable when the forces are trying to knock it over? What makes something stable? And here is the fun and little scarier part. When this kind of physics is done right, it ends up as an engineering marvel, attracting tourists from around the world. People come to click photographs. But when it goes wrong, it ends up in newspaper journals. In this video, we are going to explore the concept of center of gravity. Alright, so let's begin. So what is center of gravity? Well, every object has weight and gravity pulls on every part of it. But here is the cool part. The object behaves as if its whole weight is acting at an invisible point. Let's take this ruler for example. This ruler has weight and gravity pulls on every part of it. But the ruler behaves as if the whole weight is acting on this just one invisible point, and that special point is what we call the center of gravity. Now if you look at this ring has weight and gravity pulling on every part of the ring. But the ring behaves as if its entire weight is acting at this one single invisible point. Yes, this is wild. That point isn't even on the object. It's actually outside the object. That's right, the center of gravity can be outside object as well. But what does that actually mean? Well, let's bring back our ruler again. Now, imagine if you could magically turn off gravity on every single part of the ruler and then turn it back on, but only at this one special point. And if you choose that point right, then the object would fall, rotate, move exactly the same way as before. And yes, you guessed that right, that's the center of gravity. It's as if the gravity is not acting anywhere else, but just only on that single point. That's how it behaves. Same thing with the ring. If you remove gravity acting on all the other parts of the ring and replace it with a single force, that is the gravity acting only at that one point, then what happens? The object behaves exactly the same way, like nothing has changed. And that invisible point is called the center of gravity. That's what we really mean when we say gravity acts through the center of gravity. So if we had to give a definition, in simpler terms, here is what center of gravity is. Center of gravity is the point where an object's entire weight can be considered to act. Now that we know a little bit about the center of gravity, the next real question is how to find center of gravity. Because the process of finding center of gravity really helps us understand it better. So here we go again with the ruler. And what's the simplest trick to find the center of gravity? Just balance the object. So I'm going to identify a point. Let's say I'm assuming this could be the center of gravity and I'm trying to balance this ruler or the scale using a wedge. Nope, it's not balanced. The scale is tipping. What happened? Well, this is not the center of gravity. That's what happened. Let me try again. This time I'm picking a different point. Like this. Placing the wedge again, not balancing. Why? Because the ruler isn't just balancing, it just keep tipping to one side and it means it's not the center of gravity. Okay, let me try again. Never give up, right? Yes. This time I've identified a point here, the midpoint to be precise. If it's a 7 centimeter ruler, that's exactly 3.5 centimeter. And I place the wedge there and to my surprise, yes, it's balanced. So what does that mean? This means this is the center of gravity. Remember the definition of center of gravity? Center of gravity is the point where an object's entire weight can be considered to act, which means the ruler's weight is acting through the wedge. Exactly why it wasn't balancing earlier. The wedge wasn't under the center of gravity, so the forces weren't balanced. But now there is a reaction force from the wedge that perfectly balances the weight and the object stays stable. And just like that, we have successfully found the center of gravity. You must have noticed the center of gravity of the ruler is at 3.5 centimeter, right? Which is the midpoint. Actually, center of gravity is at the geometric center of symmetrical objects, which means the cube, the cylinder, and the sphere will have center of gravities at its midpoint. The cylinder's midpoint, the cube's midpoint, and the sphere's midpoint. Yes, that is, center of gravity is at the geometric center of symmetrical object. Alright, now it's time to take a look at our balancing toy. Let's try to debunk the myth, or rather understand the physics behind it. Do you see the two steel balls out there? Yes, these two. These two balls are placed in such a way that the toy is designed so cleverly that their center of gravity lies right on this line, and to be precise, it lies exactly at this particular point. So if the center of gravity is at that point, it's just like the entire weight of the toy is acting at that single spot, which means that's the point where the support is given, and because the weight is acting through the support, the toy can balance. That's how the self-balancing toy and all the other self-balancing toy works. So in this video, we discussed what is center of gravity. What is center of gravity? Center of gravity is the point where an object's entire weight can be considered to act. As you see in this, it is at the midpoint for the ruler, and it can also be in the empty space for as you see in for the ring. And how do we find the center of gravity? We find the center of gravity by just balancing the objects, right? If the objects balance at a particular point, then that is the point of where the center of gravity is. And we also saw that center of gravity is at the geometric center of a symmetrical object. The 7 centimeter ruler's center of gravity is at 3.5 centimeter.